Okay.
Further beyond.
Hello, welcome to the lesson. Today we're gonna do the exercise real quick together. It won't take too long. Here, so you can compare your solution with my solution. So, and then we're gonna move on to something. So the exercise was how does one... Oh yeah, remember to always, if someone talks on the Discord, then just forward that to me. Yes. So the exercise was, we want to be able to broadcast. We want to be able to broadcast messages to all clients. So when a client joins, or when a client leaves, or when a client sends a message, we want to be able to broadcast that to all users. So I'm just gonna make, on the server main, I'm just gonna make a broadcasting function. So I'm just gonna make a function called broadcast. Did we have a naming convention? We did camel case, right? Okay, camel case. So broadcast, we're gonna broadcast a message. I'll just do that as a char pointer. Message. Make that const actually, just to be sure. And then we'll do a size. So we'll just do an int message size. And then what we'll do is we'll just loop through all of the users and send a message to all of them. So I'll use loop user max. Whoops. What? The fuck? Okay. Oh, auto format. I gotta turn it off. Okay, so we're gonna loop through all users. We're gonna check if this current user is even a thing. You check like if users.I is active. If, oh my god, if not active, then we'll return. No, not return.
Continue.
God. Okay, so we return. No. What do we do?
Continue.
Continue. Thank you. We'll continue. Otherwise, we'll just send. So we'll do user.users.I.sock. And the buffer will be the message, the length will be the message size, and then flags will be 0. Good morning.
Morning.
You're late to that thing.
I'm sorry.
It's okay. So yeah. So we'll broadcast that. So let's do that. When a user connects, we're gonna broadcast a little message saying that they have connected. So in the accept worker, once we found an index for our user, we'll make a little message. All right. So we'll do a send out a welcome message to everyone. So we'll make a little message. I'll make a buffer for the message. Shouldn't be too big. 512, sure. And then we'll use sprintf that bad boy. I'll do sprintf s because I think that's what you need. The buffer. Then it's the buffer size. And then we'll do a user d connected. No, not new line. And then we'll just give the index of the new user. So I not have stdio? No. There we go. So we'll sprintf a message. Very nice. And then we'll just send it. So we'll do broadcast, the buffer, and then we'll just do Sterling buffer. So now hopefully whenever a user connects, they should get a little message saying that they've connected, and it should be sent to anyone. Does everyone know what sprintf is?
I was just about to ask, what the hell is that?
Sprintf is like printf. Do you know what printf is?
Barely. I only know we used it in your previous one.
Yeah, printf will print to the console, and it will replace all of the specifiers with variables. So it will, that's what the F stands for, format. And sprintf is just like printf, but instead of printing to the console, it will print to a char buffer. So sprintf can be used. So in this case, it will write to our buffer this formatted message.
Oh, that's actually very nice.
It's quite neat.
Yes.
Do you need a library for it?
stdio.h.
Yeah, because I was thinking about how to append messages. I got a solution from someone else, but that was like the biggest ass sold
The
about
biggest
this.
ass.
Huge stinky ass to solve, and every
Yes.
solution was like, oh, this is huge and feels unnatural.
Yeah, sprintf is very nice. I use it. I mean, it's not really. I mean, if we're talking about modern C++, it's not really used, but I like to use it because I'm cool. I'm cool, right, guys? Right?
It would be very cool if you showed some more the S printer thing again, because I need to steal that shit.
What?
I just need to borrow that thing.
Yeah, borrow it. It's yours, my friend. As long as you have enough
Rupees.
Fun. I don't know, I couldn't come up with anything funny. Okay. Okay, so let's try to say goodbye. Good morning.
Good morning.
You're late.
Didn't want to make you feel bad for being late.
Oh, you son of a bitch. Okay. So I'll boot up the server here. We have a server. Actually, I don't even think on the client we're ready yet to handle messages. If I remember correctly, we have nothing in the client to receive any messages. So we'll set that up real quick before we try this one. If you guys are ready to move on. Still here. Clickety clacks. Oh my god. Okay, we'll just move on. Scream at me if you want me to go back. So in the client, we're gonna set up our routine to receive messages from the server. So we'll just do void. No. What was the... Do you guys remember the signature for a thread function?
Was it a D word?
D-word.
D word. And what's D word? Do you guys remember what's D word?
Nope.
Double word.
Double word. And what's a word? That's an int. Exactly. What's a word? It's a short. I don't know. It's so funny for some reason. I was thinking like doing this in like English class. It's like, what's a word? It's like, it's a short. It's like, what? Okay, so we'll do receive thread. No, we'll receive worker. Whoa, Jesus. You know, I'm actually gonna be a naughty boy, and I'm going to actually save the socket globally. Yeah, I'm crazy. So we're gonna save. We're just gonna save the server socket globally, so we can reach them from all threads.
Evil madman.
I am mad, but you can't stop me because I'm the teacher. So we're gonna, instead of doing this local variable here like a dummy, we're gonna do server socket equals that. And I will just replace that everywhere. Connect. Send. There we go. Easy. So in the receive worker, we're gonna keep it super simple. We're just gonna keep receiving forever. So he's gonna while through this bad boy. Int receive size is equal to receive.
And we need a buffer.
Very good catch. We need a buffer. We're gonna make one. Char buffer.
I have a question about where to place the buffer.
Yep.
Is there a difference if I place the buffer outside of the while loop?
Not that I know of. I don't think it's gonna affect anything actually. It's still gonna allocate the same stack size for the function.
Is it gonna deallocate after every loop then?
I suspect not, but I am not sure. Maybe in debug mode, but I don't think in release mode it's gonna deallocate anything after the while loop.
Alright.
Compiler probably knows better than us.
Sorry?
Compiler probably knows better than us.
Yes, the compiler's gonna know better than we do.
Yes.
The only difference we could make is make this static. What would happen then?
Wait, hang on. Does that just mean we can't make the size different, or does that mean we can't actually change the value of it once it's done?
Sorry, what was your first question?
Does that mean we can't make the buffer any other size if we want to resize it? Or does it mean that we can't actually change any value inside of it? Because I'm very unsure about static.
Well, we can never resize it. It's always going to be 1024. But static does not mean that we can't change any values. That would be const.
Ah,
What
crap.
does static do in this case?
Only one instance.
It's only one instance. Exactly. This means that this memory, this buffer memory, will not be on the stack. It will be in something called static memory. So it will be allocated at the start of the program, and then it will just be there forever. So that could be one way to make it faster, or faster in quotation marks. Not really, but yeah, this is another way to allocate buffers. But that would not work on the server. Why wouldn't it work on the server to make a static memory?
Because wouldn't every single thread be pointing at the exact same buffer?
Exactly, because on the server, this thread, this receive worker, will work for a bunch of different users. So that means they will all be trying to receive to the same memory, and yeah, it will be dangerous. So we cannot do that for the server, but for the client we can do that. So I'll just make the memory static. Why not? Then we do the buffer size, so that's 144, and then no flags. No flaggeronis here, baby.
What are flaggeronis for?
So the flaggeronis are for different things. We looked at them briefly before. You could do something like auto band messages, which I know nothing about. For receive, you can make a flag, for example, for reading the entire buffer before returning. So even if there comes in a message that doesn't fill up the buffer, like let's say we send a 10 size message, it will just put that in the buffer and keep receiving until the buffer is completely full, and then it will return. So there is some stuff you can do with flags that we might actually do later. But for now, we're not going to worry about flags. We're not very patriotic.
Question.
Yep.
So, why do we allocate the buffer in the while loop? Couldn't we just do it before? Or like before the while loop?
We could do it before, but now that we marked it as static, it actually doesn't matter.
Ah, yeah, fair enough. Yeah.
We could do it
The
before.
only reason now when it's static is that you can't access the buffer from outside the while loop.
We can't access it from outside the while loop now.
Yeah.
And if the buffer is static, will you have to clear it every loop as well?
No, because it will return how much was actually read. So that means we know what part of the buffer is part of the new message, and that will just bit overridden, so we're fine. And as long as we only read that part, then we're fine.
Do we not need? We could use the one and same socket to listen as well as sending.
Yes.
Okay, all right. Because I just made another socket for listening. Is that really stupid?
I don't think you can.
Wait, on the server or the client?
The client.
Oh no, on the client we need only one socket. Excuse me. On the client we only need one socket.
So it's basically.
No.
It,
Yes.
Okay. You have
Wait.
objections?
I just disagree.
You disagree?
Always.
Okay. We got a trotsig system. Alright. So we got receive size. Babadook.
We
Right.
need the. Yeah.
Sorry?
No, I was wondering. I thought it was like you were leaving space for us to give what we're supposed to do next.
Oh no. But now that you mention it, what should we do next?
We need that if statement to check if the server bugged out.
Ah ha ha! Very good, Emric. We need to check if we have disconnected. So what do we check? And why?
Receive size. Check if it's -1.
Okay, and what does -1 mean?
-1's an error. 0 is a crystal disconnect.
There we go. Very good. -1 means there's an error or a forceful disconnect, while a 0 means that the socket was closed cleanly. But we're not clean, so we're just gonna check for both. So if it's -1 or socket error, or what the hell is the OR key?
Alt GR and then you do the button next to Z, left of Z. Ah shit!
Oh, there it is. I haven't used a normal keyboard in so long. There it is. Receive size is -1. No, 0. Then we did either a error or a forceful or a clean disconnect. So then we'll do something like cool like return.
Don't forget to return -1.
Oh yeah. Thank you.
Hey, can we just return receive size so then we know if it was clean or not clean?
What?
Receive size an int, right?
Yep.
And we want to return 0 if it was like, oh, everything's good in the hood, and -1 if something's bad happened, right?
I mean, we don't. I mean, yeah, sure, but it doesn't matter. I mean, we're not going to be reading this return value anyway.
It matters to me.
I was gonna ask, what does that return value even go if you get one every day?
It goes in the. It's gonna go to the place where we spawn the.
The win main? The main?
The thread. So we can. Yeah, so we can fetch the return value of a thread.
Do you know how that sounded when it echoed in the headset?
Oh, it must have sounded great. Yeah. Yeah, bro. Okay, anyway. So, I'm a little bit loopy today, as you might have noticed. Yeah, okay, so what should we do with the message now? Any ideas?
Please, do you want to just print it?
Yeah, let's print it, baby. So we're gonna do aim print. So we'll just print. We'll just print it. We'll do this complicated thing, and then do receive size buffer. Can anyone explain to me what happens here?
No.
No? Magic?
We stop at a 0, right? Wasn't that it? We check the size.
Actually, no, right? Because the 0 won't be sent. So therefore, you stop as long as the buffer is kind of, or the valid part of the buffer.
Yeah. Yeah, so Oliver brought up the problem, right? That is like when we're sending the message, we're using Sterling. No, sorry. When we're sending a message, we're using Sterling. And since Sterling will not include the ending 0, we won't be sending the ending 0. So that means when we receive the message, we won't get the null terminator. So when we print it, we have to make sure to only print the part that's actually a message, right? And not keep printing, because there is no null terminator, so we just keep printing forever.
Can't we just send an extra 0?
Yeah, we could.
Or like Sterling and +1.
Yeah, we could. But are we noobs or are we fucking gangster programmers? No, yeah, we could. But it's good to do this. Sorry?
Why would you send an extra byte?
Exactly, it's an extra byte. What do you think we're made of bytes or something? Grow on trees?
I'm so sorry, guys.
Yeah, you're on thin ice. No, but yeah, we could totally send the 0 as well. Actually,
We are expecting a buffer of 1024.
what?
Aren't we?
Sorry.
So when we send a message, kind of sending a message, I would expect it to be at least 1024 characters.
Yeah.
But we're only sending like 3.
Yeah.
But we're hoping to send or receive 1024. So sending an extra byte should be.
Okay, now you listen here, mister. We don't think like that. No, yeah, yes, of course, we could send the null terminator, but the standard actually for strings is to send the length before. That is the standard for sending strings over sockets. So we prefix the string with a length, and then we read that many bytes off of the string. That is actually the standard for reading strings. So
Is that how the sockets work? Like you get the receive size? Does it actually like add it to the beginning and then it just reads it and it abstracts that away? Or
no, I mean then we're talking more about binary when we're gonna send binary data, because then it's gonna be like, okay, what are we expecting right now from the string? And we say we're expecting a string, so then we will read 4 bytes first to be like, what's the length of the string, and then we'll read that many bytes off of the string. But we don't have to worry about that right now. We're going a little bit off topic. But this is not the main thing we're gonna be doing, sending strings over. It's just sort of a easy way to start out. Either way, we're gonna do this specifier for string, so that we, instead of just passing in a null terminated string, which we don't have, we'll pass in first the size of the string and then the string itself, so that printf knows how many bytes to read. And hopefully now something should happen. Compile errors. Oh no! Receive worker already defined. Wah! Okay,
This
so
happened
I'll
to
do
me
is
too.
I'll just wrap everything with the if client thing. Just put it at the top. And I'm gonna do the same thing for the server. Can anyone explain what went wrong here? What does this error mean?
Isn't that because we have 2 D words that have the same name, and that's like having 2 functions with the same name, which is a big no-no.
We have 2 D words with the same name. I don't think we've declared a D word.
2 functions with the same name, 2 metrics.
Yes. We have 2 functions with the same name in 2 different CPP files. And that's a big no-no. Big no-no. Can't do that. So I'm just gonna wrap all of the code in the server main and the client main with if server and if user, which means that if we're compiling server, then the client file will be completely empty, essentially. And when we're compiling client, the server main code will be also removed.
I did the loser solution by renaming them.
Okay, that's good as well. I mean, we could also mark them as static. We could also do this. Great. We could also do that.
This one I don't understand.
Yeah, couldn't we also use header? No, not header. Child class. Like do inheritance from virtual classes.
Doors right there, dude. No. No, yeah, I mean, yeah, we could. I mean, there's a billion ways we could have solved this. One would be inheritance. I'm not a fan of inheritance. You might know. I will specifically teach you not to do inheritance ever. But yeah, we could do inheritance here to solve that. But why make it complicated? We can make it simple.
By the way, all the nice, cool, sexy in school people, don't forget to send your mic stuff when you're giving cool feedback and questions to Emil, so the people who aren't here can also hear. So
What?
so he's not just talking to himself.
Oh, yeah.
Oh yeah.
Forgot I had you with it.
Ah, it's cool. It's cool. Yeah, but no. Yeah, there's a bunch of ways we could have solved this, and inheritance would definitely be one of those ways to solve that. But we're cool. We're a new age, so we're gonna not do that. But we could do static. Does anyone know what a static function is?
No.
Is that like local to the compilation unit or something?
Yes. Static in front of a function means that this function will not be exposed to the rest of the program. So it will only be relevant for the compilation unit, or the file, essentially, that static function is in.
So it's like making it private to the file then.
Kind of like you make it, yeah, you can see that you're making it private to the file. And that means you can have functions with the same name as long as most of them are static.
Why did you use static for that? That's
It's
super
they're
cursed.
they're reusing words. You know, it's stupid. Yeah, static means like a billion different things.
You're like, don't
Except if you're us, then we
Yeah.
do what we say, not what
static
we
or
do.
static, you know, so it's
I'm gonna fucking hold on. F7? Which keyboard settings have like F6 and stuff? I don't remember. Visual Studio Code. Control Shift B. Oh, whatever. Control Shift B. Compile it then. I don't even think it worked. Okay, so now we have a server. Fantastic. So let's hook up a client to this bad boy and see what happens. Nothing happened. Can someone else connect?
I think it wrote something, but it disappeared instantly.
I think that was on the server.
Oh, right, yeah.
If I open up another client. Nope, nothing.
Did you start the thread?
Can anyone explain to me why we're not getting anything?
did you hook it up? Like the function you just wrote?
Nope. That's the problem. We didn't even start up the thread. That's kind of dumb. So we're gonna start up the thread. So let's just shut down everything. So we will start up the thread. Any of you guys remember how to do that?
Create thread.
Create thread. There we go. Create thread. Whoops. Oh, goddamn it. Alright. So we're gonna give it thread attribute to 0. Stack size 0. Start address. Receive worker. Parameter. We're gonna use do null pointer now because we made a global function like maniacs. And then creation flag 0, thread ID 0. There we go. Now let's see if something happens. That's just the client. Should have a server first. Okay. Oh my god. It's the worst part of everything. Hey, user 3 connected. User 0 connected. I don't know why user 3 connected is still on the screen. That's a little bit scary. User 1 connected. Hooray! Okay, so we seem to have some semblance. I have no idea why this is still on screen. I wonder if that's a bug in
I think, Amy, I had that problem as well.
Oh yeah?
I think, are you sending the user that just connected the message that they connected?
What?
Like, when someone connects, if you just send it immediately, like you don't check if it's the user that connected that you're sending the message to.
Yeah.
Yeah, for some reason it stays. I don't know if that's because they get it immediately from startup.
Hmm. Yeah, that might be something weird.
In the engine kit, maybe? If there's like a bug.
We do it before eng init. That's a little bit scary. Maybe we should do it after. Maybe we'll do eng init first.
Yeah, I have this bit where I printed, oh, I connected before I initiated engine, and it would never leave. So, yeah, that could probably have something to do with it.
I checked the...
Oh, there, now go away.
The engine print uses, like, engine start time or something? Or,
Yeah, that's probably why actually, yeah. So if you do it before eng init, it's gonna be a little bit weird.
Yeah.
Because eng start time is not gonna be defined to anything. Sweet. So now we have broadcasting. So I'm getting messages for when I connect, but also when other people connect. So now let's take a yeah. Okay, guys, listen. Guys, listen. I was thinking about going a little bit longer today, since I came in so late. Can I get a raise of hands for everyone who wants to stay a little bit longer? Maybe an hour, maybe 1 hour and a half.
What does longer mean? Yeah, what
time are you
talking?
Half an hour.
About like an hour, maybe.
Yeah, but what hours are we talking?
What do you mean?
What time? To 16? 16?
Yeah, to 16.
I have to leave at 3:30 at the latest.
Same here.
Oh, okay.
3, unfortunately.
Ah, okay. Yeah, then we'll leave at 3.
No, just do the recording.
Yeah, well, we can catch up later on.
Yeah, leave them behind.
That's true. Okay, maybe we'll do a little. We'll see. Okay, you know what? We'll fucking see. We'll go to 3 and maybe we'll keep going. We'll see. Maybe you look a little bit tired. You're getting a little bit cranky. Maybe I'll leave early.
I'm so far ahead that I'm already at like 17.
Oh, you're so fucking smart. No, okay, I'm kidding. Sorry, that was so mean. I'm kidding, Milan. That's good. I don't want to be mean.
You said you were kidding when you said he was smart? Yeah.
No, I mean. Yeah, let's take a coffee break. So we'll be back. 2 at 2. So, I'm coming.
Wait, is that the moon? That's like the one. Avoid the carbon. This guy talks about that. Men häng kvar, vila. Okej, spring.
Om det händer ibland inte och man har en annan man som ligger och stör.
Welcome to class.
Som game designers liksom vetat så mycket hoppas vinna koden att läsas så måste läsas.
Don't ask, don't tell.
Jaha, fan det är 4 minuter kvar. Eller mouth.
Så nu har skickat ett meddelande som är 1024 karaktärer. Är det inte en nolla i slutet oavsett vad?
Va?
Är det inte en nolla i slutet oavsett vad?
Om du skickar 1024
karaktärer, exakt.
Nej, då om du skickar 1024 karaktärer får du bara 1024.
Ja, precis, men i slutet, alltså på 1025 karaktärer.
Men du skickar ju bara 1024.
Precis, men när vi läser av den, är det en nolla i slutet? Så att de vet om att den ska sluta. Vad finns det där?
Ja, whatever else is in memory.
Right,
så det är bara garbage liksom.
Så när jag säger +1, då gäller det bara om karaktärerna är mindre än 1024?
Yes, då måste det vara 1023.
Exakt.
Och det är lite det som är det annoying.
Det jag tänkte också. Min logik funkar bara om det är mindre.
Alltså det är ingenting fel med att skicka nolla. Jag vill inte ge dig fel impression som att det är wrong. Är det du som gjort den?
Nej.
Ja.
Men du borde äta upp den.
Men äpplen är så jävla onajs. Man blir såhär nasty och så bara... Man är såhär apple gunk och apple spooch everywhere.
Jag gör det i stream. Hey guys.
I mean, you're a man of solutions, I see.
Yes.
What is up, compadros?
On this one, I take the center. And
did you have a nice break?
We're having a nice break. So they keep the on the edge.
And the queen at top. How's your Swedish, everyone? Fine.
Pretty good.
Do you know what? Okay. It's a nice attack, but alright. Hello. Let's get to seating. We'll continue. Okay, so what the fuck is up? What were we doing? Oh yeah. So we managed to receive the broadcast. Very nice. Takes two to tango. So let's also broadcast when someone leaves. So when someone leaves, we also want to broadcast that to all the users. Fuck this. Strap on, dude. Okay, so we'll when the user leaves, we'll print something cool. So we'll do we'll fetch the. Okay, this is gonna be super fucking dirty, but I want to do it because it's funny. We're gonna fetch the user index, and you might think, but Ammo, we don't save the user index anywhere. Like on the user, there's no index here.
Maybe you didn't, but I did.
Okay, Mr. Smart Boy.
Yes.
I'm gonna do you one better. So
Oh.
how do we figure out the user index from a pointer?
Oh, I didn't know that one.
I have an idea.
What's the idea, Oliver?
I look through the array and then check if the socket is the same.
We could do that.
We could start at the pointer of the 0th element and work out where we are. Take the difference and divide it by the size.
What?
I like your thinking. We're gonna do this. User index is equal to, that's snake case, is equal to user, and remember we have the pointer to the array, right? Because the array is just a pointer. So we know that this user is somewhere in that array. It is gonna be the array base pointer plus whatever index it is times times the size. So we can just do user minus users. And the neat thing about this
Can I ask a question?
yes.
So, yeah, I have my user ID X, right? And I
Sorry?
get that from, we have user ID X, and hang on. Wait, if I'm user minus users,
Yes.
shouldn't that be inverted, or am I do I not understand this?
So user will never be bigger than users, right? No,
Yeah.
sorry, user will never be smaller than users, right? Since users is the base pointer, and we can only go up from the base pointer, right? We don't have a user at index -1, for example. User will always be bigger than users. So if we take the user minus the base pointer of users, we should get like how much memory is in between user and users.
Then you need to divide that by the size, right?
So that's the smart thing. I don't know. So we're actually gonna print.
This.
I think you're right. Actually, I think what you're doing works because when you do math on pointers, it knows the size of the text.
Yes. So that's
So I
the
think
thing.
that just works.
Yes, that's the thing. A pointer arithmetic in C++ will take the type size in mind. So when you're doing like an array, for example, instead of doing array and then square brackets 5, you could do array plus 5, and that will just give you the pointer to the 5th element in this array.
So that to the size.
No, not without giving the size. So it will be smart enough to know, okay, what is this pointer actually pointing to? What type is it? So when you do +1, it will take that size and offset by that.
There's like a performance to do that.
I'm not sure. I don't think so.
You're gonna have.
Compile time, so I don't think it's
I think it's gonna be. It's gonna be slightly slower because it has to load the size, but it's not. It's not gonna be anything worth worrying about.
This is terrifying and incomprehensible to me. You're gonna have to show this
I don't
off.
know why we did this. This is so dumb. But anyway, we're gonna do it. So we're gonna print that. We're just gonna print the user index. I don't know. This is sometimes good to know when you're doing some when you're doing arrays, for example, when you're doing data structures. Sometimes it's good to know just from a pointer which index is this pointer. Sometimes it's good to know.
Huh. I just felt smart enough to save the user ID as an int in the struct and then just reference that.
Yes, that was actually the smart thing. So anyways, let's see what the print gives us.
You were about to say there was something neat about this.
What?
You were about to say there was something neat about this, but then you stopped mid-thought.
Yes. So if someone disconnects, let's see what happens. User 0, user 2. Use 0. Please leave.
I still have the one where user 1 connected. It still appears. How did we remove that?
Sorry?
What? Oh.
Oh yeah, put ng in it before. But yeah, so it seems to work. I mean, the reason I think it works is that we don't get a number bigger or equal to 4. So all numbers are less than 4, and we only have 4 users. And we don't, yeah, so that tells me that this is working. So that's good. So pointer arithmetic, when you're doing subtraction, like this, getting the difference between 2 pointers, it will give you the size included in that difference. So it will give you the memory distance divided by the size of the pointer. So that's good to know. This is totally fucking unnecessary information. I don't know why I did this, but now you know. So may it help you in your future. So now we've found the index of the user that left. So we can do the same thing that we did for when people joined. We can sprint F a message and then send it off to all users. So when someone disconnects, I'm gonna first set them to active to false, so we don't send a message to them. It doesn't really matter. All that will happen is the send will fail, but I don't know. Let's be thorough. We'll figure out the index of the user by the pointer. And then, baby, we will sprint F that. We already have a buffer. Since we're not using this buffer anymore for receiving, since this socket is disconnected, I'm just gonna reuse this buffer for our sprintf. User disconnected. Sad face. And then we'll broadcast that. Whoops. We'll broadcast the buffer, and the buffer is gonna be Sirlen buffer. Here we go. So now hopefully we're gonna be broadcasting when a user connects and when a user disconnects. Very nice.
You built the client.
Oops. So hopefully on your screens when you join or when someone else joins, you should get a message, and then when you leave, please leave.
Hey, user 1 disconnected.
What? I didn't see. Oh yeah, we don't print anymore.
User 2 disconnected.
All right, we don't print.
User 1
on the
connected.
server anymore. That's why I didn't see you disconnect. But hopefully you guys should be seeing that it works. So that's nice. So broadcasting is done. We know now how to broadcast to all users. Very nice. Very neat. So let's actually do something fun instead of doing just text printing like a. It's boring. So what we're gonna do now is that we're gonna, instead of just being you go in, you send just text messages and then leave. Instead we're gonna make a game, okay? Because we're game developers, we wanna make games. So this is the bad part about having a mic. I'm just like standing fucking. I have to carry this with me. So we're gonna make a game, right? Because that's what we want to do. So what we're gonna do next is that when we spawn, when a user joins, we're gonna spawn something, spawn some sort of player in the game, and then we're gonna try to sync those with every client, so that every client has a little box moving around. And you can play the game. It's gonna be a pretty boring game, but we'll start. We have to start somewhere. Okay. So let's get rid of this. I don't want to hear it anymore. I'll get back. I'll also print F the disconnect message so we see that. What am I doing? Buffer. I'll also remove the broadcast. Actually, we don't need any of this anymore. It was just to test. Nope. Oh yeah, yeah, good point. Ink print. Thank you. There we go. So we'll use print then instead. We'll remove this as well. So, what do we do? I'll make another file. So I'll just right click on source, make sure that you have all files here visible. Whoops. Versions. Oh, okay. Make sure you have show all files, and then right click on source folder here, and then I'm gonna new item, and we'll make player.h. And then we'll also make a player.cpp. So we're gonna make a little struct, or a class I guess, to represent the player. So in the H file I'm just gonna make a class player. So we'll do bool alive, it's false. Make an int x.
Could you real quick go to server main? Just one part I missed there.
Where?
Okay, yeah, just the ink print real quick.
What the hell's
Done.
happening here? This Duckcast is like decapitated. But you guys are fucking ruthless.
Fix it.
Okay, cool. Right, so we're just gonna make a simple player, just a alive bool, and then an x and a y, and that's it. And I'll make a draw function. Draw. So then I'm just gonna declare this function in the CPP file. Oh my goodness. Player, colon, draw. And in the draw we're just gonna do ing fill rect. So we're gonna do it at x and y, because that's gonna be the player x and y. And I will use them 32 by 32, makes sense. And I will also set a nice draw color, ing color, exit color. What's a good color for the player? Red. Brown.
Green.
I vote pink.
I wanna hear hex codes. Okay, someone give me two hex numbers.
0x00FF00FF.
Okay, I need. Give me two letters or digits. CA.
Dead baby.
Okay, dead beef. I like that. CA dead beef.
Oh right.
Actually, that doesn't fit. We'll remove the CA. I actually don't know what dead beef looked like, but guess we'll find out. It's not completely. It has a little bit of opacity. I don't know how that's gonna work. Okay, so we'll just include engine.h to get the drawing functions. Okay. So let's try this out then. We'll go to the server. Oh, I actually do have. Oh, nice. We'll go to the server, and in server main, we'll just try it out real quick. So we'll just make a player class. Just set its x and y to something. 50. 200. Include it. Oh yeah, it's a class, so I have to make them public. Go. Remember, in classes everything is private by default, so we'll just make them public here. And then in server main, we'll use make a player, a dummy one, and then draw it here after the clear. So the player, draw. Okay, let's see what happens. Hey, we have a player, and it actually kind of almost looks good. Man, you connect within like 1 fucking millisecond of me opening up the server. You guys are hungry. Right, okay, so we have a player little here. Little baby. That's good. Not very interesting though. So, now we want to do it so that every time a user joins, we'll spawn a player somewhere. We'll make it random where they spawn. And we're gonna send over to that client like, hey, you have been spawned a player and it's right here.
Could you please just show me the draw function?
Yep. How are you guys doing at home? Are you guys good? You need anything?
Goddamn.
You good?
Stupid Unity tendencies.
Hey, good.
I can't
good.
hear you, Philip. No one can hear you.
Okay, thank you.
Philip says they're good.
Philip, you look very good today, actually.
Thanks. It's good.
Okay, so now we have drawn a player. Very nice. But let's still do it now so that when we're gonna have, we're just gonna do the server first just to make sure the backbone of everything is working. We're gonna wait until a user connects, and then we're gonna. I should walk around. Let's see. So we're gonna do so when the user joins. Comfortable?
Yes.
We're gonna spawn a player. Okay. I'll be back for you. Oh no, I'm turning into Joseph now. This is what Joseph would do. Yeah, Joseph Fares. Yeah, he's a touchy one. So we'll actually do in the player class. We're gonna do an array. Excuse me, I had something in my throat. We're gonna make an array of players, and we're just gonna make it global because that's the way I roll. So we'll do an extern players, and then we'll define max. I'll do player max.
What was extern in this context, man?
Yes, good question, Oliver. Player max. Okay, so what does extern mean? And what does this mean? So, first of all, I'm going to describe the problem that extern will solve. What if we do this? What's wrong with this?
Would it be created multiple times because if you include a player in multiple files?
Yes, exactly. That's the problem, Oliver. Right now, if I compile, let's see what happens.
Couldn't you just make it static in that case?
I'll get to that, yes. So here we have the problem, yes. Players already define a player.object because two files, player.cpp and server main, are now including player.h. And an include is essentially used to copy paste, right? So it's going to copy paste that header into both server main and player.cpp. So they are both files are declaring this players array, and that's a problem because just the same as with functions, you can't declare a global variable with the same name in different compilation units or CPP files, because then it's gonna get confused. So we have a problem. How do I make a global array that can be accessed from multiple files? And as Frederick said, what if we make it static? Seems logical. What did static do? You guys remember?
Nope.
Does anyone remember?
Contained in the object, the compiler.
Yes. So static means it will not be exposed to the symbol table. We don't need to talk about what a symbol table is, but what static means, it will be a local variable or a local function for that compilation unit, which means that when player.cpp includes player.h, it will get a local variable named players, and when server main includes player.h, it will also get a local version of players. What's the problem with that though?
You want to access the same players array from both files, right?
Yes, exactly. They will get their own unique array. But we want to be able to change this from main and read it from player.cpp, or potentially change it from many places. So we want to have the same array for everyone. Does this make sense?
So is that what extern does? Like,
Kind of, we'll get into.
alright.
But do you understand why static doesn't work here?
Maybe, but static kind of has different meanings if it's a method and if it's a. Doesn't it?
Yes, it has different meanings. But in this case, what static does. So I'm not sure to interpret the silence as you understand or you don't have any questions to ask.
I have too many questions. I don't even want
So say one question.
We don't know what question to ask.
We're talking about the weirdness of static being used for so many different things.
In this case, static is anti-static. It's like not static at all.
Yes.
So
This is the
static
worst.
means you can have multiple instances of it.
Yes, so static in this case is a bit weird because usually when you use static, it means to be global, right? It's like you make a static class variable, for example, that means it's global. Or global, there's one instance, right? So it's just kind of weird that they are using static here for a different thing.
But isn't this a variable?
This is a variable. What do you mean?
Yeah, so wouldn't it have that definition of being static that you can only
What?
So one definition of static is that it's like a static class variable, like you mentioned. You only have one instance of it. You can access it from wherever, right?
Yes.
Isn't this a static variable? What's the difference?
It's not in a class.
So when it's global, it's a different thing. So then it's more the static of a method declaration.
Yes. So if it's outside of a class, that means it's a local to that compilation unit. But when it's in a class, that means it's global.
Just make a new keyword like local.
I didn't fucking make C++, okay? I don't know what to tell you.
So what if it's a local method that you make static?
A local what?
A method or a function or whatever.
In a class.
Yeah.
Then that would just be accessible statically in the class.
Yes,
Okay,
then would.
Okay, so it has nothing to do with if it's a variable or a
No.
function. It has to do where it is. If it's in the class or if it's
Yes.
Okay, done.
Yeah. So if it's in a class, then static means one thing. If it's outside a class, then it means something else.
Great.
It doesn't mean what it says.
Yeah. My person does seem to like macros.
Are you using macros?
I mean, this basically.
Local and external. Internal external. That's so better.
Oh my shit fucking dog.
Oh, that's not equal.
Oh, my bad.
Okay. We're just gonna move on. It's not important to know what the difference between static and not static and static in classes is. What we're gonna use is something called extern. We're gonna use extern, baby. What is extern? Okay, so with functions, Do you guys remember the difference between declaring and defining a function in C++?
Yes.
Declaring something you do in header files, where you just type out like the signature and then use a semicolon, right? Something like this, like void shit function, like that. Whoops. This is a function declaration. What this tells C++ is that somewhere in this program there's a function defined called shit function. So that means you can compile code that uses shit function, because it will assume that somewhere in the program you have defined shit function. That's a declaration. It doesn't need to know exactly what shit function does when it compiles. It just needs to know that there is a function called shit function. That's a declaration. The problem with variables is that when I type out a variable like int apa, whoops, these are always gonna be definitions. So here I'm defining an integer called apa. So there was seemingly no way to declare a variable, saying like, okay, here's the name of a variable that exists somewhere. And that is what extern does. If you put extern in front of a variable, it does the same thing like a function declaration. Extern int apa.
So do you also have to then type it out in a CPP file for it to exist?
Very good, Oliver. Yes, exactly. Now it will work exactly like a function declaration. So we can declare it, but then we have to make sure to actually also define it somewhere. Because we're only saying, hey, int alpha exists somewhere. I don't know where. It's gonna exist somewhere. But then we have to make damn sure that we actually define it somewhere.
But all this is exclusive to the C language, right? This is coming from the C language.
And C++.
Yeah, sure. C++ is inherent from C. So.
I think this is in C. Yeah, I think so.
This is C, purely C.
I think this is purely C. Yeah, I don't know.
So external is C's way of saying declares, but it's
Yeah.
somewhere.
Yeah, declarations of variables.
But then when you connect to a DLL, then you also have external, right? So therefore you use define it in the DLL instead. Then.
Yeah, extern can be used in that way as well. To say like, if you extern something as DLL import, that means okay, this is extern. It's just a declaration, but it's not defined in the program. It's defined in some DLL somewhere that we're gonna load later. So extern can be used for that as well. But in our case, we just want to use extern to declare variables. So we're gonna declare this players array here. Whoops. So now if I compile, let's see what happens. It worked. Very nice. So that's neat. So then instead of in server main then, instead of just making a hard-coded player, let's loop through all of the players instead. So we're just gonna do for auto player, whoops, in players, player draw. Makes sense. Whoa! What you once said too. Yes. Okay. So now we're getting the problem that Oliver said. Unresolved external symbol, and then the players array. What does this mean?
We haven't defined.
We have a defined array. Very good. So that's the problem. This is exactly the same problem as when you declare a function but you don't define it anywhere. You're telling your program, hey, there's a function called poopy diarrhea somewhere. So it's like, okay, I'm gonna call it and trust you on this. But then when linking time comes and it's time to actually link those functions together, then it says, hey, you told me there was gonna be a function called poopy diarrhea, but there is no function called poopy diarrhea, so it gives an unresolved external symbol. Yeah, so we have failed our program here. And the exact same happens here. We're saying somewhere there's a variable called players that has an array called players, but we didn't make one. So I'm just gonna do it in player. So here I'll just do a player, players. Player. Nice.
Do you also have to do the player colon? Or oh no, it's not in the class, right?
Yeah, it's not in the class. But so that is why.
Wait,
maybe
no,
you
no,
have
no, no,
wondered-
wait. Bring back the player CPP thing.
Okay. But that
Thank
is
you.
why you guys might have wondered when you have been experimenting with statics in classes, like you're making a static function, a static variable, it will always say like, oh, you have to go and define it somewhere. And you might have wondered, why do I have to do this? Why do I have to put it in some CPP file? And this is exactly why. Because static in classes is doing essentially this.
So it's literally reverse. Static is the opposite of extern outside the class.
Yeah,
and static is
buddy.
extern in the
J.
class.
I mean, I guess my guess is that static. My guess is that static was used in C in one way, but then probably in some other languages, static came to mean something else. Like maybe static was later repurposed to use for classes and structs in other languages. And then when C++ came along and they wanted to do the same, people were using static to refer to class globals, and they used kind of, okay, we'll just do the same even though we've used the word before for something else. I don't fucking know. It is what it is. It's an old language.
I never wondered because I never touched them.
What?
Statics? Yes, statics. I never touched them, so I never wondered.
Oh, okay, that's good. But for those who have wondered, yes, that is because they're doing exactly the same thing we're doing now, just with a few more steps. And a little much more complicated. Okay, so nice. So now we have a player array. Very cool. Like Yuan said, is it pronounced Yuan as well?
Yeah.
Okay, it's Yuan. Okay, cool. Like Yuan said, we should check if the player is alive before drawing them. My god, I'm struggling so hard with this. There we go. So we'll do if player alive, a liver. Actually, I do if not player alive, return. Not return. Fuck. Continue. I swear, I've been fucked over so hard by typing return instead of continue. So many times.
I have a question.
Yeah.
Are we going to add more funky stuff after if player is not alive?
Not really. You could do an if statement.
Then why? Yeah. Then why do we do? Then we don't really need continue, do we?
I don't like nested if statement. I don't fucking. Just take me for my word here. It's just a style. I have the style of I like to do exclusivism, like exclusivitary if statements.
Excluding.
Yeah, I don't know what the fucking name is. Yeah, I don't know. I just come into the habit of doing that. If you don't want to do it, that's fine. You can do it if player live draw.
Continue function actually takes time to execute compared to skip more than nothing.
But it's gonna continue anyway, so it doesn't matter.
Because I think we did a test on this in our C++ course where we saw that using continue instead of like having the functionality inside of the if statement actually causes like a slowdown in the program just by a couple of milliseconds.
It's not gonna be milliseconds. It's gonna be nanoseconds. Yes, it might. Okay, I'm not an expert on this, but yes, it might cause a an instruction cache miss or something like that. But in the end, it's sort of up to what is more common. Is it more common for it to miss, or for the if statement to be true, or is it more likely for the if statement to be false? So in the end, I don't think there is a rule here for which is faster or slower. It's sort of up to what is it doing. But in the end, like when it's compiled with release, it's not gonna look anything like this anyways. It's not gonna follow this structure at all. Right. So now we're checking if the player is alive, and then drawing it if it is. Very cool. So let's run it. Alright. So of course we're not doing any code right now to actually spawn the players. So we're not gonna be seeing all that much. So let's do some coding for when a user connects, we're actually gonna spawn a player for that user. So we'll make in the player class, I'm just gonna make a spawn function, spawn, and destroy. Whoops, whoops, whoops. Fucking hell, dude. Fuck! God. Like, I don't have I don't have feelings in my ring finger and little finger, so it's kind of hard to know sometimes which button I am on with my left hand. Player. Okay, and the spawn, I'm actually gonna send in coordinates for the spawn as well. With X and Y. Spawn X. Yeah, we'll do that. Okay. So when we spawn, we're simply gonna set the bool to true. Whoops. Alive is true, and then we'll just set X to spawn X and Y to spawn Y, and then destroy is going to be equally simple. We're just going to set alive to false. Super easy. Annoying you?
As a Frederick might snap, but we're pretty good.
You like that shit? Okay, so okay, so okay, so now we have a way to spawn players, or we have a function for it at least. So now when a player connects, we're gonna spawn that player, and when it disconnects, we're gonna despawn the player or destroy. So in the accept code here, when we are accepting a player, I'm just gonna do players and then the user index. I did user index as snake case actually. Whatever, it's just gonna stay snake case. We'll use spawn. Let's do rand modulo 800 and then rand modulo 600 for the X and Y there. And then we'll just include stdlib to get the rand functions. Nah, we don't care.
You're gonna have to slow down a little bit. I don't even know where the fuck you are right now.
Yeah, it's a lot of code. We should split this code up at some point.
No, not just where, like, not just like where is players supposed to be?
Player?
In the accept.
Yeah, in the accept code. Right after we print this, like, ah, you're connected. Oh yeah. Then we spawn it.
Rand the remainder 800 and 600. That's to make sure the rand function doesn't go above 800 on X and 600 on Y.
Yep. So it's gonna return big number, but we don't want to spawn something off screen, right? So we want to remain with that bad boy.
And what was the lib header again?
stdlib.h. Standard library. Yes.
Så då kan alla hennes int så
You got plenty of sleep.
That feels like that. Okay. So now hopefully whenever someone connects, it's gonna spawn. And I'm actually also real quick, when someone leaves, I'm gonna despawn. So when we have the user index, I'm just gonna do players, whoops, players, user index, destroy. So when someone leaves, I'm gonna destroy their player character, their avatar. Yes, Emmerich?
I was scratching my head. I wasn't
okay.
asking a question.
Where you define player max?
What? It was in player.h here. Let's go, please.
Oh, never mind. It's very slow.
Okay.
Were we in the receive worker when we were doing the destroy thing?
Sorry?
Were we in the receive worker?
Yep.
Could you please show that bit again? Because it's giving me red squigglies now.
Sorry?
Didn't we broadcast there that someone left?
Yes, I remember that.
Yeah, no, exactly.
I was just waiting for 20 seconds to this variable process. I guess I'm reading.
Yeah, I think that's a bug, right? I've also had that lots of times.
It just close it down.
Yeah, it's a bit annoying and it's happened to me like I think several times an hour. Like in the last part of
See that?
it was super annoying.
I don't know if it has like how
Yeah, I'm a magic. Are we ready to try it? Are you ready? Alright, so people are coming in and they're getting their avatar. And then someone left, and then their avatar got disconnected. Like there's so little time left before you will start. We will start ignoring your messages.
Is it full? Is the server full?
Yes,
I
we only have 4. Okay,
Yeah,
I'm gonna open up the server so more people can get in actually.
I get the IP as well.
Yeah, here's the thing. I keep like crashing every time I try to join now, and I don't know if it's a me problem
wait,
or if it's a
I have
small
user
problem.
max 128 actually.
What's your IP by the way? 10.20.2.178. It's the same as in Beans Review.
I'll post it in. I'll post it in the channel. And it's kind of weird that usually there doesn't seem to be more than 4 people connected at one time. I wonder why that is actually.
Hey, Emil, would you like to come in and take a look at my cool shit that's not working?
Yeah, sure.
I haven't changed it. I was able to. I've been, going around in there pointing, the Parabalabamba players.
Okay, I'll try.
Oh, you fucker. Så den connectas. Det första vi gör är att vi skriver här.
Du fick en...
Jag fick ju inget play. Jag väntar på att du ska det är därför vi fastnar här på receive. Just move up. Okay, you guys are having a lot of fun, I can see. I'm glad about that. But okay, so let's see if we can quickly replicate at least the position of the player to the client real quickly, and then we'll take a break / end the lesson. So yeah, the fun is over. Okay, so real quickly, let's see, how should we do this way? I'll do it in 10 minutes. Yeah, so we're gonna be modifying Oliver. Please. We're gonna be modifying our receive function on the client now, so that we don't just receive a message and display the message. We're gonna receive a message and actually try to interpret what is going on. Okay. So now it's time for us to sort of define what should a message look like. What should a message look like in our game? So there are many ways of doing this, but the first. So here's the problem, right? Let me paint the picture. The problem right now, right, is that we have multiple things that can happen. We have the case where we spawn a player. Okay, great. We have the point where we spawn a player. And we have the case where we destroy a player. So we have two kinds of messages now that we need to handle somehow. And of course later on we're gonna have, is someone moving, did someone shoot a bullet, did someone send a chat messages or something. We're gonna have a bunch of messages. So how do we determine what kind of message here are we receiving? Does anyone have any ideas for how we could do this?
Just guess. We could
Guess?
We could send an Edom as the first part of the message.
That's a great idea. Oliver?
Or compare the size, maybe?
Compare the size, that's another good idea. We could guess. That was a good idea as well, I think. For a while. Until we make a wrong guess. So yeah, that's the general thought of it. We're gonna send something called a protocol. I don't think it's called a protocol, but we're gonna send some sort of identifier in the beginning of the message. It's called a header. That's what it's called. We're gonna send some type of header in every message. And the header is gonna describe what type of message has come in. So for example, when we spawn, in our header we might send a single byte that just has a 0 in it. And we say, okay, if you get a header with a 0 in it, that means the next byte coming up is going to be player spawn data. There's going to be some amount of bytes here describing, okay, someone has spawned, which index, blah, 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 and so on. And then for destroy, we're going to say in the same header, but instead of 1 in it. Or something, it doesn't matter. So if it's 1, then we on the client side can say, okay, I got a 1 in the header. That means this is player destroy data. So then it's gonna read the rest of the data as if it's a destroy message. So it's called a header, and it's important that the header is the same size, because we're gonna have some known part of the message always in the beginning to be like it's known, it's agreed what the beginning of the message is, and that part of the message should describe what the rest is. Okay, so it's called a header.
How would you do that easiest? Do you have like the same variable in the beginning of every struct, or do you like artificially add bytes manually?
It doesn't really matter. We could do it as struct. We could do it as a writing bytes individually. It doesn't really matter. We're just gonna do it the simplest way possible for now. So yeah. So in the player then, we're gonna have to do some restructuring here. Okay, let's What's the best way here? Let's I'm gonna refactor the server main codes. I'm thinking actually let's do this on Monday instead. I think it's gonna be better because people want to leave, but you're tired.
I'm kind of excited to see how you solve this problem.
Yeah, I know, and I'm excited to do it as well, but I kind of want to do it.
Are you tired?
No, I just don't want people to miss it. But yeah, I don't want people to miss this. This is important. So let's do this. Let's do it on Monday. So we'll leave it at that for now. And then on Monday we'll continue. We're gonna refactor the server, and it's quite like mental heavy work as well to get all of that shit set up. So that's why I kind of don't want to do it at the end of the day. I want to do it at the beginning. So let's stop it there. And then on Monday, we're gonna continue on, refactor a little bit of the server, and start looking at sending headers to our clients. It's gonna be heavy. It's gonna be heavy as fuck.
Heavy duty.
Heavy duty. Cool. So let's take some final questions, final thoughts before we end the lesson for today. I'm sorry it was a short lesson today. I'm sorry. I don't have any excuse. I'm sorry, but yeah, it happens. So yeah, do you have any questions? I saw one hand there.
Yeah, I'm just thinking, should we do a check to see that what connects with us is valid? It actually is a player or a client that wanna play or something like that?
Yeah. So that's important. You brought up a very important question about security, right? Because the question was essentially, should we check if the thing that's connected to us is actually a player that want to play the game? And the short answer is there is no way to check. There's no way to know if what connected to us is a bot, or if it's a player, or if it's just like a random message that came from nowhere. There's no real way to know the difference. The only thing we can do is kind of look at what they're sending to us. Like for example, if the header doesn't make sense in a message, then we can pretty safely say, this client's not playing by the rules, disconnect them. Or if they're spamming a lot, if we say something like, okay, if you're sending more than maybe 200 messages a second or something, then we're saying, okay, you shouldn't be able to do this. We've set up the client to not do this. Disconnect them, because they're probably a bot or something. But that's sort of the problem with internet, right? There's no way to know what is the message coming from. Is it the same program that we've set up? Is it a completely different program that someone else has written? It's no real way to know. And that's the whole like internet security thing, right? That's why DDoSing exists, right? Because someone can just connect and you send garbage to our server, and there's really very little we could do about it.
Yeah, I mostly just wanted to make sure that what we send and receive actually sends and receive. I didn't think about security at all. I just thought that if a client connects, we need to know that we can send the data to it or something.
Yeah, that's just up to us to make sure the client is matching with the server. That's really about it. But it's a good question.
I have a tiny question about reinterpret
Yeah. Well, I thought that C casting was just a reinterpret cast, but for some reason I got a compile error. I'm not quite sure. I have very little experience with static cast and reinterpret cast and all those things. I tend to be a C cast kind of guy. But for some reason I was getting an error. I'm not sure why, but I assume there was some safety check in there to make sure I couldn't do it. So then reinterpret cast will just be like bombard that safety check and no, I know what I'm doing. But I'm actually not too sure. But technically there's no difference between a C cast and a reinterpret cast.
So if you're using one because of readability, you're not screwing yourself over. Because I just like doing the brackets.
Oh, no, not that I know of. It might be a problem with cast operators, conversion operators. That might be a problem for you. Because I don't think reinterpret cast will use those typecast operators if you have them for some reason. Yep.
When the server receives a message, it's gonna read a certain amount of times, right?
Yep.
Say that you were to send like a collection of 50 char arrays, but very small, but you still read all of them in succession, right?
Yes. So that's one of the problems we might bump into, kind of what you're talking about. The problem is, what happens if the server is kind of slow? Maybe it's spending a long time on one frame. And what happens is actually that one client has enough time to send 2 messages at once. So it's, on its end it sends them to separately, but as far as the server, it's so slow that they are both in the queue before we call receive. And that's a big problem with TCP, that it doesn't actually separate between packets. It doesn't have that sort of mentality, it just sees it as a stream.
So just sort of piles out.
Yeah, so that's the problem. If we do one receive and then assume that that's going to be one message, then we might be skipping over messages that happen to be in the queue at the time. So we're going to have to probably set up something for that at some point.
Is it possible that you can like all receive and get like 1.5 messages?
Yes. Yeah. And you could even get less than one. It could be that it splits up the packages. So if you're sending up quite a big message, it might split it up. So then you might be receiving only half a message.
Okay. And it's just you use like the return value to see how much you got and compare that to what you expected, and then you know if there's more. Is that?
Yes, that's kind of how you do it. Yeah. You have to somehow expect how big a packet's going to be and read exactly that much. That's where we'll be using that flag for fill buffer.
Yeah, that's the bug that's been got me all day.
Oh yeah, okay. I'm glad to have found that out for you. Okay, guys. Thank you for this lesson. I'm sorry it was short again. I'll see you on Monday. So have a good weekend. I'm gonna stick around actually for the party. So if you guys are coming to the party, I'll see you there. Bye.
Bye everyone on Discord actually. Thank you for coming. Okay, I'll see you. I love you all. Bye bye.
Good lesson, Emil.
Bye. Woo! Okay. Okay. You don't need to. Okay. Thank you. Thank you very much. God.
Thank you, Emil.
Yeah. Thank you too. See ya.
Yeah.